Good afternoon, everybody. I'm going to give a sort of a primer course on how to use these two models that we think are very valuable in trying to manage crop load. I really want to also congratulate Greg Peck for bringing the pollen tube growth model to New York. I think it's a tremendous addition. I'll make just a couple of comments about how bloom thinning fits for us. But my main focus is going to be on these two post-bloom thinning models. I start with just a review of this precision chemical thinning process that we've been promoting now for about 10 years now. It starts with, it's a protocol to use sequential thinning sprays and try to sequentially reduce the crop load down to some target number. We begin with the blossom thinning sprays using the pollen tube growth model has been described earlier. But starting with the petal fall spray and the succeeding sprays after petal fall, the carbon balance model becomes an important tool in deciding both when to spray and at what dose to spray. So for each one of those succeeding sprays, we use the carbohydrate model to try to guide us in both those two decisions. But after each spray, we use the fruit growth rate model to try to determine what happened with each of those sprays to guide whether or not we spray again. So it's possible in some years you might get all your thinning done with the blossom spray and the petal fall spray and stop. And the way that you judge that is through the use of the fruit growth rate model. In many other years, you have to spray again at 10 to 13 millimeters. And then in many years, that's enough. But in odd years, when thinners don't work so well, we have to come back in with the last spray at the 16 to 20 millimeter stage. I want to first start with just a review of the carbon balance model. This model was developed in the mathematical sense, primarily by Alan Laxo, but then he and I together put this together to help with thinning. It's based on two simple parts of the tree physiology. First is what is the photosynthesis process, which produces the carbon to support all the action of growth functions of the tree. And that's primarily defined by temperature and sunlight. So when we think about the impacts of sunlight and temperature on what's going to happen with thinning, we're primarily thinking about how much carbon is going to be available to support fruit growth. The other side of the equation is really the uses of that carbohydrate, and that's dependent mostly on temperature. And so we have algorithms in this model that then distribute the carbon that's produced to the places that need the carbon, fruits, shoots, roots, trunk. And then we come up with a carbon balance, whether there's enough carbohydrate to support all the functions that the tree is doing, or there is a deficit. And we do this by day. Now, starting, I don't remember when, well, I do remember that in the 2000s, I was running this model by myself, by hand. It was very time consuming. And so I really had the dream of putting this up for growers to use themselves. And somewhere in around 2010 or so, we got this up on the NUA website. And I want to go through some of the particulars and some of the information that's contained in the carbohydrate model as you see it on NUA. I also want to mention that while I was gone on leave, Pollyanna was able to produce a phone app where the same information from NUA can be seen in a phone app called MaluSim. It has a slightly different look to it, but the information on the phone app MaluSim essentially comes from the NUA website. So the first thing that's important when you go to the NUA website is to pick the station, weather station. And Dan already covered some of this, but I would like to highlight that when you click on the carbohydrate model, this is the landing page that you see. And you see here the station. I've selected Geneva, New York. You see the calendar where you can pick the date you want to look at. But also down here is this small toggle switch to select a different station. And so when you click on that button, you comes up with a map. And in this case, I picked the Geneva station so that when I run the model, it will use the weather data from the Geneva station. The second thing you need to do is to pick a date. I happen to pick June 10th from last year of 2021. That was near the end of the thinning window, just to show you what it looked like through the entire thinning period. And if you're running this in real time, that would be today's date. So if you're looking at putting on a petal fall spray, it would be the date of petal fall. The second thing you have to choose or enter are two dates, the date of green tip and the date of full bloom. Now, we hope that every grower will write these dates down for their orchard so that a few weeks later, when you need to run the carbohydrate balance, you can have those dates. If you didn't write them down, we can generally provide a reasonable estimate because we keep track of it by region in the state. The last thing that we incorporated into the model about 3 years ago was this last thing you must choose, and that is how strong or how intense is the flowering. And we've just divided it down into 4 categories. 75 to 100% of the spurs are flowering, that's intense flowering. If 50 to 75 are flowering, then that's more moderate flowering. If only 25 to 50% of the spurs are flowering, that's light flowering. And certainly below 25% of the spurs flowering, it's extremely light and would not warrant thinning. Once you enter that, the model will automatically calculate for you and will show you this page with a tabular form of the data and then a graphical representation of the last column of the data, which is the carbohydrate balance average. Now, I point out with the arrows, the important things that I think you should pay attention to when you use the model. And right here, I have this starting at green tip in 2021, which for Geneva was March 26th. I don't think that this year in 2022, we're going to have such an early green tip. I'm predicting it more towards April 15th, but the model will start based upon the green tip date that you put in as you started the model. And so this table, you could scroll through from green tip all the way down to today's date. It has the first 2 columns are maximum and minimum temperature. I've kept these columns in there for 2 reasons. First is there's long-standing pomological wisdom saying that temperatures above 80 degrees give much greater thinning. And so I want growers to pay attention when temperatures are high. The second pomological wisdom is that when nighttime temperatures are above 60 degrees at night, you get a lot more thinning. And so by looking at those temperatures, you can kind of get a sense of what's going to happen. But what's not built into pomological knowledge is the third column, which is solar radiation. Generally, this is a number that people don't pay attention to or know about, but it's in a scale called megajoules per square meter, and that scale goes basically from a very low 2 to 3 to 4 number up to about 30. So intense sunlight in New York is about 30 megajoules per square meter. And you can see just in these numbers that on March the 30th, it was a sunny day. We had more than 20 megajoules. And then 2 days before that, it was very cloudy. On March 28th, we only had 4 megajoules in the entire day. The next 2 columns are really the results of the model. And they're the carbohydrate balance for that day. And generally, it's a negative balance if there is a deficit. And then the next column is what we call the 7-day weighted average or thinning index. And this considers the daily carbohydrate balance for 2 days before a spray and the day of spray plus 4 days after the spray. So once a chemical is applied, the hormone type chemicals, NAA, Maxell, those things, they're absorbed by the plant and they continue to act metabolically within the plant for 3 or 4 days after application. Therefore, the temperatures and sunlight for 3 to 4 days after application have an impact on thinning. Now on the next slide, I'm going to scroll way down on that table, down into the thinning period. It starts on March 28th in that year, but now I'm down into May of 2021. Now I said full bloom was on May 2nd. So once we get into bloom, then the model will start coloring the cells of both the carbohydrate columns into one of four colors, and they're listed here across the top. If you sprayed on that day, March 2nd, full bloom, and with these conditions before and after the spray, we would expect mild thinning, and hence they're all colored blue. And for this whole period, you see all the cells are colored blue. If they're colored green, we would expect good thinning. If they're colored pink, or a light orange, that'd be very, very good. But if they're colored red or pink, then you would have excessive thinning. But one of the most important things about this model is to avoid over-thinning events when thinning is going to be excessive and people don't realize it and they spray anyway. The last column is this daily recommendation. If you happen to thin on that day, what Terence Robinson would suggest you do as far as rate. I want to explain this just a little bit. We publish each year in what's called the Cornell Recommends for New York State, a standard thinning rate for each variety. And so there's a different standard thinning rate for McIntosh than for Gala. What we're saying here in the model is that taking that standard rate on this particular day, if you thinned on May 2nd, you should increase the rate of chemical that you're applying because it's going to be very mild thinning and you won't get much out of just a standard rate. And we tell you to either increase a small amount or a large amount. The most we ever tell you to increase is about 30%. Also, we have these little circles with a color in them. And these are whether there's low risk of overthinning or some caution, or there's a high risk of overthinning. And so you see during these days right after bloom, there was always a low risk of thinning. So in summary, what the model has are these important data points to help you understand what's going to happen when you spray. I should mention again that there's both the web-based version on NUA and there's the mobile phone version at malusim.com. If you go to malusim.com, you can download an app for free. And there will be a new updated version for 2022. So you should probably all re-download the app after April 15th. The second thing that we've added in recent years is this use of relative bloom density to predict thinning response. If you have a moderate to light bloom, often thinning response is much lighter. If you have an extremely heavy bloom, you get a greater thinning response. And that's built in to the behind the scenes table that helps give the recommendation in the last column of the table. Now, I didn't mention, but I do want to mention right now that there's a column before this thinning recommendation, which is a degree day column that we added a couple of years ago for two reasons. This is a degree day accumulation since bloom because of a long-term study we did of 17 years of applying the same treatments at Geneva. We found that the best thinning was always when degree days were between 200 and 250. And so we've now come up with some additional recommendations based on that degree day number. We suggest that a petal fall spray should go on somewhere between 110 degree days and 130 degree days after full bloom. If you apply the petal fall spray sooner than that, it almost is ineffective. But by waiting until that moment, then you get the best effect from a petal fall spray. As I just said, the best timing for the 12 millimeter spray is between 200 and 250 degree days. And then there's also a window about 100 degree days later between 300 and 350 when you can apply when fruits are big and still get some thinning. Now the model also predicts thinning efficacy based upon the 7 days, 2 days previous to the spraying and 4 days after the spraying plus the day you spray. It's a complex formula, weighting the day you spray and the next 2 days after you spray higher than the 2 days before spraying or the last 2 days in this formula. So that's the basics of how the carbohydrate model works. Now, how do we use it? We try to time each one of the 3 post-bloom sprays based upon temperature degree days after bloom. So in recent years, we've been telling people, watch the carbon balance model, run it every day. And then when you get close to the 110 degree days after bloom, try to find a day to apply your petal fall spray. About a week later, it turns out, we generally get into the 200 to 250 degree days, and that's when we would try to find the best day in which to apply the 10 millimeter, 13 millimeter spray. And then if we need thinning, more thinning, we would put on a last spray between 300 and 350 degree days after bloom. Now, let me show you how this worked in practice. These are 3 locations in New York. Hudson Valley is where Milton is. Williamson is in Western New York. And then Peru is in the Champlain Valley, where Mike Baisdow is located. And I put down graphs from the carbohydrate model, along with blue boxes showing the 3 different post-bloom thinning windows. The vertical line here at the beginning shows when full bloom was, and I'm sure you can't read the dates, but you can tell that the time from full bloom to when the petal fall window opened, 110 to 130 degree days in the Hudson Valley, was relatively short. In Western New York, it was even shorter. And in the Champlain Valley, it was just about the same as in the Hudson Valley. The main point I want to emphasize is the number of days in each window varies with how cold or warm it is. In the Hudson Valley, the petal fall window was quite long, about 5 days long, because it was cool. But and you can tell the carbon balance was positive. That's what happens under cool weather. But you can tell when they got to the normal thinning spray of 10 to 13 millimeters, the window was very short. It was only 3 days long. And you had to pick a day in those 3 days to spray. Whereas 18 millimeters, it was a little bit longer. The exact opposite happened in Western New York. When they got to petal fall in Western New York last year, it was hot. And so the petal fall window was only 3 days long. But then by the time we got to 10 millimeters, it was cooler. And so we had about a 6-day window on which to choose the best day to apply our 10 millimeter spray. But when we got to the 18 millimeters, it was warm again and much shorter. And you can see that each one of the 3 regions had a different number of days in each window because we're working off of degree days. Now, the carbohydrate model will help you understand that by this column of accumulated degree days. We put into the model this black box that surrounds the degree days when we're in the prime window between 200 and 250. So this was for, I can't remember exactly where this is, but on May the 26th, they accumulated 200 degree days since bloom, and we would have said that's the first day you should put on or could put on your 10 millimeter to 12 millimeter spray. And then you have 1, 2, 3, 4, 5, 6 days before the degree days accumulate past 250 in which to apply your spray. So within those 6 days, you would tend to look at days without rain, days without temperatures in the 90s. And so you'd come over here and you'd look, well, on May 26th, they had a 90-degree temperature. I probably would avoid that day. But then I've got relatively cool temperatures, and the last day is a 75. So probably pick one of these days, either the last May 30th or May 31st, to put on that 10 millimeter spray, assuming it wasn't too windy. So you have to battle all of those factors, watching temperatures, watching rainfall, watching wind speed, but hopefully you can find one of those 6 days on which to apply your thinning spray. And this is the way we used the data last year in some of our thinning meetings. This is a slide that I pulled from a presentation I gave for a 10 millimeter type spray. And I looked at that chart on the previous slide and I told people, you have basically between May 26th and May 31st to apply your 10 to 13 millimeter spray. I suggested that any one of those 6 days would give relatively mild thinning. Now, how did we know that? Well, we get that over here from the color of the boxes. Now, you can tell that it's mild thinning from the blue color of the box. A little previous to that, it was green, but during the period of time that we're going to be suggesting they thin, it was all relatively mild thinning. The temperatures were only going to rise up into the 60s and mid 70s by the end of that 6-day window. But the big problem was that the carbohydrate balance is generally positive, and that's where we see this upper thing up here. Through this whole window of the optimum thinning period, the carbohydrate balance was positive, indicating we wouldn't get very aggressive thinning. So I said the carbohydrate surplus and cool temperatures will give mild thinning, therefore use full rates. What did the model suggest? It said to increase rates by 30% for every one of those days if you were going to thin then. But I also indicated that because of the cool temperatures, even with increased rates, it was unlikely that that particular spray would give enough thinning, so we would probably be forced to come back with a rescue spray at 18 millimeters. All of this depends on the temperatures and the sunlight that you happen to get when you enter these various thinning windows. So we know, or we can predict at least somewhat, what we think is going to happen when we spray at either petal fall, or we spray at 10 millimeters or at 18 millimeters. But not knowing exactly what happened leads us often to feel like we're on pins and needles, because we have to decide if we're going to spray again before we really can see how many apples have dropped off. If you wait to look at that visually, it takes about 2 weeks from any spray to really see how many apples have fallen or will fall. You wait for their stems to yellow up, and then you look at how many are falling. But often we need to make a decision on whether to respray in only 1 week's time. Therefore, the development of this fruit growth rate model that Dwayne Green developed in one of the years he was on sabbatic here in Geneva, with primarily Alan Laxell and myself to a little bit, has been an invaluable resource in helping us understand what happened once we spray and whether we should spray again. The model will predict what percentage of the fruits on the tree will drop and what percent will persist. The difficulty is that the model requires manual measuring the diameter of fruitlets twice over a 4 to 5 day period, starting 3 days after the spray and ending about 7 days after the spray. The difference in their diameter between the first measurement, 3 days after the spray, and 7 days after the second measurement, 7 days after the spray, helps us categorize how many fruits will drop and how many fruit will stay on the tree. This then requires these 5 steps. I guess I mislabeled the last one, but it requires the grower to physically count the total number of flowers clusters on each of 5 trees. And we have this rule that we do not count bloom on 1-year wood. So I wanted to comment, Mike's results show that often this model overestimated how much thinning, because sometimes those fruits on 1-year wood continue to hang on. We try to thin them all off, but if some of them hang on, we end up with more fruits than what the model estimates that we would have. Once you make those initial counts of the entire tree, then we tag 15 spurs on each of those trees, and then after we sprayed, 3 days after application, we measure every one of those fruitlets on 15 tag spurs on 5 trees, which totals to 375 measurements. And then we wait 4 days and remeasure again, and based on that, we calculate the percent of persisting fruits. Now, in the last, well, we've been using this model, I don't remember, maybe 10 years now, and people get tired of the measuring and frustrated. So we've thought of different ways we could simplify it. Now, there's 4 simplifications that we've done to this model, which maybe Dwayne Green doesn't agree with all of them, but they're just sort of ways to try to make it not so onerous to use the model. The first is that we discarded the need to keep track of the order of fruitlets within each cluster. So initially we would label each fruitlet like you see in this bottom picture, 1, 2, 3, 4, and 5. And then we would measure them in that same order every time. And that made people frustrated to have to find where's fruit 2 and where's fruit 3. And so now we just measure them in any order. And behind the scenes, we rank them within the cluster from the biggest to the smallest each time to run the model. But the grower does not need to keep track of the order they're measured. The second thing we've done is develop this degree day way to decide when to make the first measurement and when to make the second measurement. Because it turns out that in cool years, you should make your first measurement, say on day 3, but you should wait about 6 days to the second measurement. In hot years, you can make the first measurement on day 2 and make the second measurement on day 6. But by doing degree days, we can consistently measure these at the right time. So we suggest that you wait till 50 degree days have elapsed after the spray and make your first measurement. And then wait till 100 degree days after application to make the second measurement. Now this number I've changed a little bit in the last year or two because I used to say wait till 120 degree days, but by then sometimes it was too late to make another application. So I've shortened it to the 100 degree days. And then the last thing we've done is if you use the the phone app version, the Malusim version, we've included error detection protocols to eliminate the problem that I see repeatedly when growers send me data, and that is an error in typing in the data or error in measurement that gives excessively large growth rates, and that will overestimate how much thinning you did. So now I have error protocols built in to the Malusim version to correct that. Now going back to this output of the NUA model, let's suppose you chose to spray on this day on May 26th when you had exactly 200 degree days from bloom, and it's a good timing. We would then wait till 50 more degree days have accumulated till we got to 250 and then make our first measurement. Now, because it's so cool, after application, it's 1, 2, 3, 4, 5 days before we measure. But by using the 50 degree days to time your first measurement, you will get the proper timing, and then you wait till 100 have passed before you make the second measurement. Now I want to spend just a few minutes talking about the Malusim version of the fruit growth rate model. When you download the app and you open it up, one of the first things it will ask you to do is to put in the base numbers for the block you're trying to predict thinning. And so you have to choose how many trees you're going to be measuring, how many clusters, and the typical recommendation is 5 trees, 15 clusters per tree. And then there's generally 5 fruitlets in each cluster. That multiply that out and it's 375 fruits. Then we said you had to count the total number of flower clusters on each of 5 trees. And in this particular case, they varied from as low as 58 on tree 2 to 101 on tree 3, and the average was 75. So 75 average flower clusters times 5 gives you that tree had a potential of 376 fruits. But the grower has decided he only needs 85 fruits to have a full crop. Then you go out and you measure. And here you can see is the way the data is entered on this. You can enter it on your phone out in the field while you're measuring. It has across the top tree 1, 2, 3, 4, and 5. And then when you select on each tree, it has cluster 1, 2, 3, 4 through cluster 15. And this is the second measurement. And it says when you measured the first time, there was only 3 fruitlets in cluster 1. There was 4 in cluster 2. There's 4, 4, 4, and 3 and 4. And so it automatically will pre-populate all the fruitlets with how many it was before. And then you enter the new number as you measure it. If you don't like it, you can clear all the measurements. But this is the way you enter it. There's also a phone recognition piece to this. If you want to just say the number, it should recognize it, but you have to double check that it correctly heard or could understand what you said, and it put it in the right cell. But once you do that, then the model will run and you end up with this sort of a output. I just put in here, this was a Honeycrisp block from 2021. The grower wanted 85 fruits, and measured the first time on June 1st, the second time on June 4th. So only 3 days between measurements. On June 1st, the average size was 6.3, and on June 4th, it was 8.4. Based on all the fruitlets measured, it already calculated that from the 376 original fruits that are on the tree, that petal fall spray knocked off most of them, and there was only 109 left, and the target was 83, 85. So we got very close to the target in just one spray. Why was that? Because in Western New York, it was warm at petal fall. And in fact, almost all the thinning in Western New York came from the petal fall sprays last year. At 10 millimeters, it was much cooler, and we got very little thinning. And that's the value of using both a carbohydrate model and this MaluSim fruit growth rate model. So in this case, I told the grower, stop. You've got a few more fruits than you really want, but if you thin again, you might over thin. So best to hand thin off about 20 fruits, 24 fruits per tree. There also is a button here where you want to see view model data. If you click that button, it will bring up this table that I have pasted in the bottom here. For each one of the 2 dates of measurement, June 1st and 4th, it'll show you the diameter of the largest fruits, 10 millimeters of the largest fruits, whereas the mean was only 6. But then at the second time, the biggest fruits were 14, and the average of all was 8. So these biggest fruits are the ones that grow fastest. And then it shows you that the biggest fruits grew 4 millimeters over those 3 days. And so half of that is 2 millimeters. And then it tells you how many are going to drop off and the predicted fruit set. Graphically, it shows you the same up there. So I want to finish with just a little bit of thoughts about this fruit growth rate model. It's one of the greatest tools that we have now in our toolbox to help manage precision thinning. I preach and preach and preach. Go measure fruits. It's not that big a deal. It'll help you be so much more confident. Before this, people on the carbohydrate model, people would tell me their stomach would be in knots all through thinning season, hoping they didn't overthin. But the use of these 2 models have given them a sense of confidence and calm as they go through thinning. The problem is it's time consuming and tedious, and people get tired of doing that. And so sometimes I have a convert who will start measuring fruitlets for a couple of years, and then pretty soon I check with them and they're not doing it anymore. So I realize that that's a serious limitation to the use of the model. The second problem is I continue to find every time I look at grower data or even our own errors in measurement, either when they typed it into the spreadsheet or when they measured it. And so without me going through meticulously and looking for errors, I didn't trust anybody to use this model without me double checking them. However, now with the error detection tools that we have in our new version of the MaluSim phone app, I feel more confident that you can use this model without me fearing you get the wrong answer because of errors. So the solutions are this cell phone. Well, there are 3 possible solutions coming down the pike. A number of people said, why can't we use cell phone fruits and have the cell phone have an app that would calculate the diameter rather than us having to measure it with a caliper? That's being done by 2 companies which we're working with on this large SCRI project, in which you can take pictures of the fruitlets and then send them to one of these 2 companies, and they will calculate the percent drop instantaneously for you. We're working with both of them. The Fruit Scout company, you take a picture of each fruitlet. You hold a small card next to it that's got a symbol on it, so it uses that as a reference to determine how to measure the fruit. And then you go back and take a second picture 4 days later or 5 days later, and it will calculate the growth rate. So, but it's still a job because you got to take 375 pictures each time and upload them to this company. The second company, called Farm Vision, uses a slightly different approach in which they take a video going down the row, tree to tree, and they can do that in the first time, and then repeat it and match up the fruits and calculate the fruit growth rate. I know that Fruit Scout is selling a commercial service this year to any grower that wants it to take pictures and use their system to use the fruit growth rate model. I think Farm Vision is also selling or beginning to sell a service to do the same thing. And we're trying to look at both of them and determine how we feel about both of them. But I would say if you really don't want to measure fruitlets, contact one of these two companies and see if you can work with them using your cell phone. The second approach is Todd Einhorn's idea for Michigan State to actually go pick 200 fruits, put them on a light table and scan their diameter using computer vision. And do that twice and you can get the same answer. A third idea came from Tom Kahn, in which there's a particular instrument that you can look at the reflectance of specific wavelengths of all the fruits on the tree, and the ones that are going to fall have different reflectances. And so you could categorize fruits that way. So in conclusion, what I'd like to take home from this is that the MaluSim model, whether it's the NUA version or the MaluSim FONAP version, is essential to predict thinning efficacy before you put the chemical in the tank. And it's also extremely useful to warn you when there will be excessive thinning and over thinning, and then you avoid thinning on those days. It's available free on either NUA or at malusim.com. It's easy to use and should be run on a daily basis during the thinning season. Secondly, the fruit growth rate model, I think, is a wonderful tool to determine what happened after you put the thinning spray on to allow a more informed decision on the next thinning spray. It's not available on NUA. The only place it's available is at malusim.com in a computer version, but it's still even tedious because it requires manual measurements of fruit diameter. But I'm excited that improved methods to get that fruit diameter measurement and then plug into the model are on the way, and they're going to make this whole effort to use a fruit growth rate model much less tedious. With that, I'll conclude and thank you for your attention, and be happy to discuss this at the end or now, whatever you choose, Mike, as we move forward.